We're going to look at reverse percentages. Now let's take a look at these two examples that I've got on the screen here. At first glance they look very similar. A coat costs £80, it is reduced by 10% on a sale. What does it cost now? Seems like a standard question. And a coat on a sale costs £80, the sale gave 10% off. What did the coat originally cost? Now we've got to get our heads around why these are such different questions. And the best way to do it, I think, is to consider a simple timeline. Do it for both of them. You don't need to draw this every time you do a percentage question, but you need to be having these type of thoughts. So we have the original cost and we have the sale cost. And again, we have the original cost and we have the sale cost. Just by the very nature of things, you know this is how it works. The sale always comes after the original cost. Now the costs can be measured in two ways. There's the very easy, obvious way of money, but we can also talk about percentages. And we've seen previously that the original percentage is always 100%. It never fails to be 100%. Now, in this scenario, the coat has been reduced by 10% in the sale. It's now at 90%. Here, again, the sale gave 10% off. 90%. It all seems identical so far. But now the difference. In this example, a coat costs £80 and is then reduced by 10% on a sale. So the £80 belongs over here. Here, the coat is already in the sale when it costs £80. £80 is over here. They're asking us on the first question what it costs now that it's in the sale. Here, and this is the critical word, what did the coat originally cost? They're asking us for the cost here. Now hopefully you can see that they are different questions. Now this one, if we were to use a percentage multiplier, would probably be best done like that. It's reduced by 10%, so it's multiplied by 1 but a little bit less than 1, and if we multiply by 0.9, that's the correct amount below 1 to result in a 10% reduction. And so that's a fairly straightforward £72. This is more awkward. Now there are lots of ways that we could tackle this, and everybody has their own preference. But I would advise you to do the following. We know both of these numbers. So I would suggest that we can say that 90% equals £80. And we would like to know what 100% is in money terms. And so we can do that. The answer, whatever the answer is going to sit over there. Now, if you understand the unitary method, you'll realise that we could divide by 90 and multiply by 100. Although given the numbers that we've got, perhaps it's easier to divide by 9 and multiply by 10. Once you've decided that, then you just have to do the same here. And so 80 divided by 9, whatever that is, times 10. Now this could turn up on a non-calculator paper, so let's do it as if we haven't got a calculator. £80 divided by 9, decimal points are going there. 9 into 8 doesn't go, remainder 8. 9 goes into 87, let's get it right, 9 8s are 72, so it goes in 8 times with a remainder of 8. 9 goes into 80 8 times with a remainder of 8. 8 times with a remainder of 8. It's recurring. It's going to run forever. And so if we try to multiply this by 10, we're going to get £88. We're going to be a little bit careful. £88, and we could say 88 pence, but it will round up, 89 pence. That isn't really the point of this video though, so if you want to go away and use a calculator to check it, you can. But £88 and 89 pence is the correct answer to the nearest penny. A lot of people, when they look at this question, they'll say 10%, £8, must have been £88. And you can see they're close, but it's not correct. And they will actually score 0 marks because it's just wrong. So you need to be able to identify the difference between that type of question and that type of question. And I do think a timeline is helpful in helping you understand that that percentage is equal to that amount of money. So that's reverse percentages on the right, compared to, if you like, the easier, more traditional type of percentage questions on the left.